So today we talk about correction for continuity. Now, here's our problem. We have discrete values. So there's a little bit of a gap between 1 and 2, 3 and 4, 4 and 5. There's a little bit of a gap. It actually doesn't make a complete number line. Now, remember when we did your graphs with your frequency histograms? If we used your midpoint, we said we were pretty good with that. If we used the endpoints, remember we kind of added the 0.5 and dropped the 0.5 so that we could expand those bars because they never really touched? Well, we kind of have the same problem here. A discrete probability has separate bars. If we made bars, they'd all have a little gap in between them. So to close that gap, we're technically going to subtract 5 from your lower value and add 5 to your upper value. But we have to be careful here, because when we actually do the probability, we have to be careful if it was an upper boundary or a lower boundary. So we have to know if we're subtracting it or we're adding it. So as we did before your class boundaries, remember we did, like, if your class boundaries went from, say, 1 to 5, we did the drop it 0.05 to the 5.5. We did this, and then you saw 6 to whatever this was, 4, 10. So it went 5.5 to 10.5. Remember when we did your class boundaries? Very similar situation. However, when we go to do our probabilities, we have to know, is this an upper, is this a lower? Because if it's the lower, we're going to subtract 5. If it's the upper, we're going to add 5. So the best way to do that is to work your numbers out the way you see them on a number line. Now, not really, it's kind of like if you look in the book, it's kind of not that obvious, but you can kind of see where your bars are. If you kind of look at it, I don't have this snapshot of this. If you kind of look at where they do on the left-hand side on page 261, they have C in the middle. And then on the next part, they have subtract the 0.05 and you add the 0.05. So it's kind of like, just like extending your bars, but we don't have to do it the whole time. So let's walk through a couple of examples. Now, if we're going to find the probability of getting between 270 and 310 inclusive, what does inclusive mean? It includes. Now, if we didn't say inclusive, it would be everything but those two end numbers, right? So if I'm doing 270, including 310, I technically am using 270, I'm using all these numbers, and I'm also using 310. Now, your rule is you subtract 5 from the lower end, so this guy is going to become 269.5, and you add 5 to the upper end, 0.5 to the upper end. Subtract a half and add a half. So technically you're looking at this. Okay? Now, not a really big deal when you go to do this, because these guys are binomial probabilities, so they're discrete. So you never really find the number 269.5. However, we will use that in your formula. So it's important that we kind of make sure that we catch if it's a lower end or an upper end. Now, in between, the only other thing they could say is it's a non-inclusive. It's everything but that. So I'm going to change this problem around, and I'm going to say between 270 and 310, these are not inclusive. So now I'm starting at what number? 271. And I'm ending at what number? And I'm ending at 309. So these are the guys now that you have to drop 0.5 and add 0.5 to. See the difference with the inclusive? If I say the numbers between 1 and 5, inclusive, I want 1, 2, 3, 4, 5. If I say the numbers between 1 and 5, what numbers are between 1 and 5? 2, 3, 4. So inclusive means I'm going to include my endpoints. If it's not set at all, I'm not including my endpoints. So the best way to do correction for continuity is to lay out the pieces that you think you're working with. So let's take a look at the next one. The probability of at least 158. So how do I use at least? Less than, greater than, equal to? Greater than. Could it also be equal to? Greater than or equal to 158. So this is how you start. You say, what's the first number that you can use? I'm going to use 158, right? And I'm going to go all the way out till whenever. So is that a lower end or an upper end? A lower end. So rule is we subtract 0.5. Okay, we just subtract 0.5 off the lower end. We add 0.5 to the upper end, we subtract 0.5 off the lower end. If it said more than, how would I write more than? Greater than. And what's the first number that I would use? 159. I would not use 158. So now I'm going to drop this guy. So I'd be the probability of x is greater than 158.5. See the difference? Figure out what numbers you're using. And then use your rule. Drop 0.5, add 0.5. Okay, the probability of getting less than 63. Less than 63. So what's the highest number that I'm going to be able to use? 62. So I'm using everything below this. Is this my lower boundary or my upper boundary? Upper. So rule is add 0.5. See it? You got to figure out where your endpoints are. If you don't, you're likely to use the 63, but we don't use 63 if we say less than. We don't want it to be 63. We want less than 63. Right? So it makes a little bit of sense? Okay, so what I want you to do is try it yourself once. Whether we put these equal signs here or not doesn't really matter because we will never get that number. Your discrete probabilities are only whole numbers. But we will use these in a few minutes when we use your z-scores. And so that little 1 point could make a difference. Could make a little bit of a difference. The equal sign under here generally doesn't. I usually end up keeping the same sign, but it doesn't really matter with the equal sign. So you guys try it yourself too. At the bottom of that page, try these guys. I want you to set up your probability statement, put it on a number line, and then adjust it. Okay, so according to this, I'm going to use 57, and I'm going to use 83. So, Elvis, lower end. 56.5, good. Heather, upper end. 83.5. Now, whether you put the equal signs or not, it really doesn't matter because you'll never find those. You'll never hit the equal sign when you're doing your actual binomial probabilities, your discrete probabilities. So we drop the lower end 0.5, we raise the upper end 0.5. So all you have to do. Well, when we go to use the probability, that's going to make a difference because now we're going to, when you do your in-between, you do x minus your mean. Now our x is going to be this, 56.5. No, it's just figuring out where your endpoints are. Because your bars actually, if this says 56, 57, 58, your bars actually go this way, around 56. There's a gap. There's a gap here. You have no, everything is discrete. So if I'm going to go from 57 on, like this, there's a gap between 56 and 57. So we want to press that gap together. It's the same. Remember when we did your frequency histograms? We did all those bar graphs and everything. Sometimes we use the midpoint and we said this way we had no gaps, or sometimes we use the class boundaries, we pushed them out 0.5 so that there was no gap between our things. When your intervals went 1 to 5, 6 to 10, you technically go like this. Here's 1 to 5. There's 1 to 5. I got a gap between 6 and 10.
So like, why is it 57? 45? Why is it 56?
Because we're going to meet halfway. We're just going to meet it halfway. Technically, like we did here, we just met it halfway. And it really doesn't matter. We're just expanding our bar. If you kind of look at, when we do the next one, you'll be able to see their graph is a little bit better than the one with the dotted line one. Didn't really do it justice. But when we do a probability, you'll see the difference. Okay, the probability of getting at most 54 successes. Courtney, how'd you write that one? X is less than or equal to 54. That's the most I want, and I want to include it. So now, am I using 54? Yes. Is it an upper or a lower? Upper. So Samantha, how'd you correct it?
I added 45.
Okay. It's an upper, so we add 0.5. You need to know which one it counts. If it just says less than, then I have to start at 53. But at most means it's that and less. That's the most it could be. All right, just to do. All right, so I should put ABC below this. All right, so which statement corresponds to this first one? We read this as at least 45 successes. At least means think money in your pocket. I have at least $45. I have that much and more. So this hooks up to D. How about this next one? How did I read this one? B, at most. That's the most I'm going to have in my pocket. Bless you. Or less. There's your B. Number 11. A, fewer than. Do I count 45? No. I'm going to count 44 and down. I have fewer. I don't have 45. And the last one, more than. Okay, are we okay with the inequality signs, with the equals, and when it has the less than? Oh, you know what I find helpful is think money in your pocket. If I have more than something or less than, if I have less than $10, can I spend 10? No, because I don't have 10. All right, now this guy, correction for continuity. 13, what does 13 match up with? Do we have, so we have, what's the first one for this guy? I have 90, right? So is it my lower end or my upper end? Lower. So what are we going to make it? Greater than 89.5. Don't use the 89. We can't use 89. We have more than 89. In this one, what's the first number we can use? What's the first number we can use? We can use 89, right? Is it a lower end or an upper end? Lower. So drop this. And what do we get? 88.5. How about this guy? What's the highest number we'll be able to use? 89. Is it a lower end or an upper end? Upper. So what's that become? 89.5. C. And your last one is D. What's the highest number we can use? 88. Can't use 89. So bring this guy to 88.5. Anybody struggling with this part? This is really important that you get this, because in a minute we're going to be putting this into your Z-scores. Okay. All right, so let's take a look at how we use this now. We're going to do the same exact thing that we did before. We're going to find your N, your P, your Q. We're going to test. We're going to test that we're allowed to use this. If this test fails, we stop. If it's good, we have approximated a normal curve, and then we're okay to use this. If we're good, we calculate your mean, your standard deviation. We need your mean and your standard deviation to use in your z-score formula. Because your z-score formula says x minus the mean over the standard deviation. This is not your sample that we did before. This has nothing to do with that. This is a binomial probability. We apply your correction for continuity to your probability statement. Whatever the x is less than, greater than, or equal to, we apply it to your probability statement, and then we use your z-score formula using your corrected x value. And the rest is the same. We look up on your table to find your z-score, and we see if it's left or right of it. So let's give this a try. 34% of people in the U.S. say that they make a New Year's resolution. You randomly select 15 people, and you ask them if he or she is likely to make a resolution. What is the probability that fewer than 8 respond yes? So the first thing we have to do is test this. If this is type P, what's Q? 66. Good. What's N? 15. There's my N. Pull this information out first. Don't even do your probability statement yet, because this has to pass this test. We test to see if N times P is greater than 5, and N times Q is greater than 5, greater than or equal to 5. So we do 15 times 34, we check, and we do 15 times 66. And if this one's good, then the 66 one has to be good. So we plug this in, and this is greater. Great. What is it? 5.1? Thanks. So we're good to go. And of course, if the lower one works, then the upper one, the larger one, has to work. Now, we go for our probability statement. How do I make this statement? X is what? Fewer than 8. Less than 8. Now, I need to correct this for continuity. So, what is the highest number, God bless you, that I'll use? Do I use 8? I use 7. Is it an upper boundary or a lower boundary? Upper. So how do I correct this? X is less than 7.5. There's my X value. Now, in my graph, I need to find my mean. I need to find my standard deviation. So here's the case. We use your formulas. N times P, which we know, right? Are you okay with me just putting that down? And your standard deviation is the square root of N times P times Q. You already know your 5.1, and we're just going to multiply that by your 0.66 and take the square root. So let me cheat and go to that page. And so 1.83. Thank you. Okay, now we have your information that goes over here. 5.1 goes right here. Where does 7.5? To the left or to the right of this? To the right of it. Somewhere up here. We want the area shaded to the left. That part, your z-score still works the same. So now we're going to say z equals x minus the mean over the standard deviation. And what's our x value now? 7.5. Minus 5.1, we want it to be positive, over 1.83. And you're going to come out with a z-score of about 1.31. Same as you always did. Once you get to this point, it's the same as you always did. This is not your central limit. This is a binomial probability one. It's completely different. So we look up your z-score, your area to the left, and we find it to be 0.9049. So there's about a 90%, 90.5% chance that out of the 15 people I pick, fewer than 8 of them will respond yes. Am I ever going to hit 7.5 people? No. So my 7.5 has no value in this. I am starting at the 7, but my continuity says just fix this, raise your bar a little bit, fix this in between, And I also have to use that as my x value. That's why that one makes a difference. So if you're going to use 8.5 or 7.5, it's going to make a little bit of difference. Right? So we kind of put everything together at this point. We tested first. This is important. Do your test first before you even go anywhere else. Because if your test fails, you stop. Test, find your mean, your standard deviation, correct for continuity, make your graph, see which way you're going, less than, greater than, in between, see where you're going, and then do your z-score formula. Can you use your calculator for this? Absolutely. You can still use your calculator for this. With your lower limit, your upper limit, your normal CDF one, you can use that one if you so like to do that instead of your z-score. But you still have to find these. You have to find your mean, you have to find your standard deviation, you have to correct for continuity before you put it in there. But you can bypass this little piece over here by using your calc and find it. It goes right to your area. Alright, try yourself. 3. So do we have 3 minutes? Alright, try it when you come in tomorrow morning. How's that?